Now in this video, I have a PNP 8550 transistor LED 1-blink circuit. On the collector side of the transistor, I have a 500 ohm resistor. I've got a 2-volt red LED going across the collector emitter. And I've got a 6-volt source across the front of the entire transistor. Now on the base, I've got a 22 microfarad capacitor and a switch across the capacitor, which at this time is presently opened. I've got a 10K ohm resistor, and I've got another switch S1, which is also opened. Now, at this time, the LED is on. Now, why is the LED on? The LED is on because the transistor is off and the current flow for the LED is going only through the 6-volt source. The current is flowing from the positive and through the diode and through the 500 ohm resistor. And that's why the LED is on. Now, I'm going to close the switch. Now the switch is closed. As soon as I close the switch, the LED goes off. Now, why is the LED off? The LED is off because the transistor is on. The current is now flowing out of the base of the transistor, which is what turns the transistor on, and is flowing through the capacitor. Sometime after it starts to flow through the capacitor, the LED turns on again. Now, why did the LED turn on? The LED turned on because the transistor turned off. Now, why did the transistor turn off? The transistor turned off because current quit flowing through the base. Now, why did the current quit flowing through the base? The current quit flowing through the base because the capacitor is charged up. And when the capacitor reaches about 5 volts, the capacitor is charged and current stops flowing through the base of the transistor and the transistor turns off. Now, when the transistor is off, the LED turns back on and the current is once again flowing through the volt source and through the LED and through the 500 ohm resistor. Now, initially when I closed the switch and the LED went off, the transistor immediately put 0 volts across the LED. And the reason it put 0 volts across the LED is because as soon as I closed the switch, the transistor went into saturation because this resistor here is low enough to drive the transistor into saturation. So now the LED is on, and the transistor is off. Now what I want to do now, I want to repeat the whole process. And I first start by opening the switch. Now switch S1 is open. Now I'm going to close switch S2, because when I close switch S2, this causes the capacitor to drain. So now that switch S2 is closed, the capacitor is drained, and now there is 0 volts across the capacitor. Now to repeat the process, I open switch S2. So when I reclose switch S1, the LED first goes off and then it goes on again. This is why I call this circuit the one blink LED circuit. And this brings me to the end of the video. Subscribe, like, and share. Subscribe, like, and share. Thanks for your attention.